Welcome to lesson 6.2, angles in standard position in all the quadrants. So up to this point, we have focused strictly on quadrant 1. So that is looking at between the positive x-axis and the positive y-axis, which is where you started graphing a long time ago. So it kind of makes sense that we start again there. And it's also the numbers that we usually count with, positives and so forth, and angles between 0 and 90 degrees. Today we're going to look at quadrant 2, quadrant 3, and quadrant 4, and how they are related to quadrant 1. So the first thing we need to know is that we can have angles in all quadrants. So we can have an angle in quadrant 1. And when we measure that angle, we measure from our positive x-axis going this way, we call it theta, and this is in quadrant 1. We can have an angle in quadrant 2. Standard position says we still measure it from our positive x-axis. So this is quadrant 2. We can have an angle in quadrant 3. Again, measuring all the way from our x-axis, our positive x-axis specifically. So that is all theta. This is quadrant 3. Or we've got quadrant 4. And again, we're still measuring all the way from that positive x-axis. Okay, so we start in the top right and go counterclockwise around to number our quadrants. We can call the angles in quadrant 1 acute, because they are less than 90 degrees. Quadrant 2, we call them obtuse, because they are less than 180. But in quadrant 3 and quadrant 4, we actually call these angles reflex angles, because they are greater than, we're going to say 180 is less than our angle, but it's also less than 360. And 360 is our full circle. So that's for quadrant 3 and quadrant 4. So you might remember that when we're dealing with any point on our grid, we can talk about it in terms of the distance from the origin, r, x, and y as the coordinates. And these were kind of formulas for just using doing the math with those angles and sides. So what I'd like you to do before we continue is go through this activity, and what you're asked to do is find the radius vector, so r. So that's what you're determining, r. You're also going to determine the sign. What I mean by the sign is whether it's positive or negative. But before you can do any of that, you're just deciding and identifying which quadrant it's in. So we've got 4 points, we've got 4 little grids here. So we're going to use them. And they don't need to be perfect, but just a general idea. So we've got 3, 1, 2, 3, and 2, 1, 2. And so my point will be approximately here. P. But we're not going to call it P because it has a different name actually. It's A, 3, 2. So again, we can imagine that this is a triangle, a right triangle, theta. And we can talk about how this vertical measurement is 2, the horizontal is 3, and we can solve for r. So r is the square root of x squared plus y squared, and that's on the previous page, and we established that in our first lesson. So it's the square root of 3 squared plus 2 squared, which is 9 plus 4. So we're dealing with the square root of 13. We are going to practice leaving our answers in exact value form. Okay. We need to get comfortable with using radicals. This is an exact value because when we deal with a number that doesn't have a perfect square root, it is what we call an irrational number. That means that we cannot actually represent it with a terminating decimal, a decimal that ends at some point. We also can't represent it with a fraction. So we're stuck with this never-ending decimal that doesn't repeat. So instead of rounding it off, cutting it off, at some point we're going to leave it in exact value form, the square root of 13, without punching it into our calculator. So exact value means leaving it in radical form in this case. Okay, so we are asked for R, but before that we were asked to determine the quadrant. Which quadrant is this? It is quadrant 1. Okay, because we always start in the top right and go around. We're then asked to find the sign of sine, cosine, and tangent. So sine theta would be opposite over hypotenuse, so that's 2 over root 13. Is that positive or negative? It's positive. Cosine theta is going to be 3 over root 13. That is also positive. And tangent is going to be 2 over 3. Opposite over adjacent, not adjacent over opposite. And so we're going to get positive there as well. So we've got, it's in quadrant 1. We've got my R value, and so I can determine my signs. Now remember from our last lesson that R is always positive. So if you need to remind yourself of that. Okay, so pause the video. You're going to do B, C, and D in here, and then you're going to fill in a table on the next page. So you have to do the first part of plotting these points and identifying where they are and all their signs. If you need to, make sure that you do extend that axis, and it's okay if your X and Y axis have different scales. For this part of the activity, you need to actually look back at the previous page and all those signs you identified. You're also going to look at part 2 of the activity you did before lesson 1, and you're just going to identify sign in quadrant 1. Is it positive or negative? Cos in quadrant 1, it's also positive, and I'm doing this from the example that I did on the previous page, and tan also was positive. So you're going to go through and you're going to fill in this table. Once you have this filled in, how would you summarize the information so that you could remember it? Because this is your rule, and this is something you are responsible for knowing. It's not something that's on your equation sheet. You are responsible for knowing in which quadrant which trig functions are positive and negative. So take a second, pause the video, do that. Okay, so what we're looking at here is in quadrant 1, all of them are positive. In quadrant 2, only sine is positive. Quadrant 3, tan is positive, and quadrant 4, cosine is positive. So you might have come up with any number of different ways of remembering this, but there are some other strategies to use. So I'm just going to record this data down here. So sine is positive, cosine is positive, and tangent's positive here. You don't need to do this. I'm just scrolling up. Then I've got sine, tan, and cosine. Actually, it might be a good idea to write those in. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4, until you like have that mastered, it's a good idea to label them yourself. Always use Roman numerals so you don't get confused with the actual measurements on your grid. So how people are remembering this kind of varies depending on who you talk to. I'm going to tell you a bunch of different ways. I'm going to say that all three trig functions are positive in quadrant 1. Sine is the only one that's positive in quadrant 2, tan in quadrant 3, cosine in 4. So the first way of remembering it is cast. So you start in quadrant 4, and you just go counterclockwise around. And that's the abbreviation, so CAST. So some people like that one. I personally like starting in quadrant 1. It's just a personal bias, always have. So if you're not crazy about starting in quadrant 4 and then going to 1, 2, and 3, good news, you are not George Lucas. And so what you're going to do instead is you're going to remember an acronym potentially. So the one that I always use is all students take. And you can use calculus because we're in math. I also use chemistry, but that's probably just because I'm a chemistry teacher. All students take chemistry, and that starts in quadrant 1 and counts in order. But you might have noticed that I like using sentences to remember things in the previous lesson because I also said never enter stinky washrooms to remember my different coordinates, or I said that one, and never eat soggy wieners. So there's another activity for you to do here. What you're going to do is with your calculator, you are going to punch in all of these values and you're going to find out what they are. What do you notice about the results and why is this? So pause your video and punch them in. Did you notice that for the first 4 angles, they were actually all produced the same value, just they changed between positive and negative? And for the second 4 values, they also produced all the same number, and they were all positive or negative? That's because we can use reference angles to predict values of multiple angles within our 360 degrees, as long as they are related. So we see that 35 degrees is in quadrant 1. This is going to be our reference angle. Reference angles are always in quadrant 1. And so we represent it with this little theta r as a way of remembering that that's my reference angle. It's always in quadrant 1. But we can have angles related to it. And so that's what we see, the related angle, theta. And it will help, we'll be able to find our reference angle from it or use our reference angle to determine what the standard angle is. So option 1 is I say, okay, well, I'm dealing with 45 degrees. Well, 45 degrees is actually related to 35 degrees because we're always going to measure from the x-axis. Okay, so our reference angle is always measured from the x-axis. So in this case, 35 degrees shows up here, but 45 degrees is our actual angle measurement. 215 is also going to be our regular angle, but our reference angle is measured from the x-axis. And finally, in quadrant 4, we see that still the same thing. 325 is our actual angle, but 35 degrees is our reference angle from the x-axis. So reference angle is always, always, always from the x-axis, no matter which quadrant you're in. And so you see the math down here. And when we're dealing with quadrant 2, we're always going to be subtracting our reference angle from 180. Because we're going to 180, that's our x-axis, and then going backwards from it, clockwise. Then we're dealing with quadrant 3. It's a 180 plus our reference angle, because we are going to 180 and past it. Quadrant 4 is going to be 360 minus our reference angle, because we're going all the way to our x-axis and then backwards a little bit. So we don't quite get there. So again, we can write that in terms of, to find the related angle, we're going to use those equations. So in quadrant 1, we're going to go theta is equal to alpha. Quadrant 2, we could say that alpha and theta equal 180. If you don't remember, this is what we call complementary, or no, supplementary. Complementary is adding to 90. Okay, to get quadrant 3, we're going to go theta is equal to 180 plus alpha. And quadrant 4, we're going to go theta plus alpha, which is our reference angle. So I'm going to change alpha to be our reference angle. It kind of looked like a D in that one anyways. And that equals 360. And so you can go about this any way you want. And using these equations, you can determine your reference angle or your standard angle from knowing which quadrant it's in. So let's do some examples. Label and evaluate the reference angle for each of the corresponding angles. Okay, and just for practice, I want you to also be identifying in which quadrant it is. So A is in quadrant 4. My reference angle needs to take me from 300 to 360. So you can think about it as a couple different ways. 300 plus what gives me 360, or 360 minus 300 will give me my reference angle. And that is going to be 60 degrees. And I'm going to actually label it in here as theta r. For B, I'm dealing with quadrant 2. My reference angle is here in this case. And so it needs to take me from 145 to 180. So my theta reference is going to be, how much more would I need to add? So 180 minus 145, and that is going to give me 35 degrees. My reference angle here, if you label this, you are wrong. Your reference angle is always to the x-axis, because we've got those standards of 180 and 360 defining them. So we are taking 180 and we're going past it to 225. So how much did we go past 180? So 225 minus 180 will tell us the difference, and that is going to be 45 degrees. And this is in quadrant 3. And going back to quadrant 1, we know that our reference angle is equal to our actual angle. So that is our reference angle, and so theta equals theta r, and so that is going to be 40 degrees. And so that's just interpreting it. Make sure you're always going between that x-axis and your ray, your terminal arm. Here you're given the angle and you're asked to draw them. State the quadrant and the related angles. Okay, so actually you don't need to draw them, but I always like to, just to get my head around it. It helps me think about the quadrant. This is between 90 and 180, so that's going to be in quadrant 2. Okay, and just in case I was questioning it, I could measure it out. But that's just to help me kind of picture what's going on. So my reference angle is going to be my first related angle that I always find. So I need to figure out how to get to 180. So 180 minus 159, which is going to be 21 degrees. So that's my reference angle. I can also have angles in quadrant 3 that are related and quadrant 4 that are related. So that's what it means by related angles. I'm talking about all the angles with the same reference angle. So I can take this into quadrant 3, and I'm going to go 180 plus 21. Do not forget your degrees signs. That's your unit. It's just like meters. And we're going to get 201 in quadrant 3. We're going to go 360 minus 21 for quadrant 4, which gives me 339 degrees. So those are all of my related angles, and it started in quadrant 2. So that's my answer to the question. 55, that's between 0 and 90, so that is in quadrant 1, which means that this is also my reference angle. Okay, from here, we need to find quadrant 2, quadrant 3, and quadrant 4. So we are going to go ahead and subtract 55 from 180, which would be 125. Quadrant 3 is 180 plus 55, so that's going to be 235. In quadrant 4, we're going to subtract 55 from 360, so that's going to be 305. So following the same idea as A, just with a slightly different set of values. So I'm going to leave B and C for you to try on your own. Okay, so pause the video now and give them a shot. So how'd you do? Did you get these two right? If you didn't, make sure you ask questions. If you did, that's awesome. Go to your workbook, do the practice questions that are in there, and once you finish those, you are actually ready to do your first assessment for this unit. So congratulations, and get going.